This is Mrs. Schaefer, and for the Unit 3 test remediation, I wanted to spend a little bit more time on the energy conversion of the roller coaster question. This goes directly to Chapter 5. On the review sheet, there was this diagram and this chart that you filled in. And we did some similar questions like this in our discussion. So if something is not in motion, then it only has potential energy. So if we had a roller coaster sitting right here at position A, and there's no motion in it, we can say that it has only potential energy. But as soon as this roller coaster starts to move down through the course, there is an energy conversion occurring so that there will be potential energy and kinetic energy. So as it's going down towards B, that 100% potential energy, while it was stopped, is now going to be including kinetic energy. There'll be potential energy and kinetic energy as it's going through until it comes to a stop. So at the end of our drawing, that's our lowest point in the diagram, and our A is at the highest point. Now, with our diagram in the review sheet, it had A, potential energy completed, and C, kinetic energy completed. Well, if it's at its highest point, we know energy has to total out to be the same, beginning to end. Energy only transforms from one form to another. It's never created or destroyed. So if we're saying that the highest potential energy is at A, then the kinetic energy must be at its lowest. And we don't need to have number values in this case, but we can use relative position. Then let's look over here at our point D. When we're comparing that to A, it's pretty much at the opposite end when we're looking at the height. D is the lowest point. So we can now go through and complete D, because if A has the highest potential energy and the lowest kinetic energy, D will be the opposite energy pattern. So we can have that completed in that we now have our A complete and then our D completed. We figured this out just by walking through and working on each of the patterns. All right, so now let's look at this again. We now have C and B to complete. We've completed our analysis of the energy at A and D, and now we need to look at B and C. And there is some information that was in our data chart that will help us with C, because we were told that it was decreased to 1/4 of the maximum value. Well, we know that the potential energy and the kinetic energy together in the system has to be 100%. So what would you list for C? All right, so then we'll talk about our B. So let's check and compare the four heights. We have, if we put them in order of height value, we go with A, C, B, and D. A is the tallest, D is the shortest, and C is between A and B. So we put it in order of A, C, B, and D. So B is kind of halfway between A and D, and C is about 3/4 of the height. So if we pulled out some rulers and did some calculations, we would come up with C at being about 3/4 of the height of A. So we know from potential gravitational energy that we can use this information to help us solve the rest of the problem. C, at point C, 1/4 of its value of kinetic energy is present. So that means to compare with the potential energy, the total energy will be 100. So the potential energy should be at about 3/4 of its original value. And then we talked about the position B being halfway between A and D. So we should be able to complete this chart because we can use all of this relative information to help us out. And that for point C to have 100% energy, 3/4 of the original value of energy will be potential energy, 1/4 will be kinetic energy. And B, position B, which is halfway between A and D, will have half of the original value of potential energy and half of its max value of kinetic energy. So I hope that helps. If you need to watch this more than once, then please do so. If you need to pause and take notes, please do so. Have a great day, and we'll see you next time.